Hello, Mr. Ryan. How are you today?
Good.
Good. Okay.
We got a new book today.
Well done. Well done. Okay, so let's.
Called Unleashed, Dog Man.
1, 2, 2, 3, 2, 4. Okay, so this is an array with numbers. What's the maximum?
1,
What?
3, 4.
4. What's the minimum?
1,
What's the average?
2, 2.
Average, you add all these numbers divided by 1, 2, 3, 4, 5, 6. Yeah? Okay? That's average. Right? Sum divided by numbers. That's average. Got it? Yeah? Does it make sense?
1, 3,
Okay.
5, 8.
You're okay with this
4,
concept, yeah? Okay, so what's the
14 divided
what's
by
medium?
1,
Remember what's medium?
2.
What's medium? Medium is you saw these numbers, right? If 1, 2, 3, what's the medium?
2.
If it's odd number, you pick the middle one. It's in the sorted one, right?
Yeah.
How about 1, 2, 3, 4? What's the medium? Medium. What's the medium? Do you still remember? You pick in the sorted. You saw these numbers, yeah? 1, 2, 3, 4. You pick the middle two, even number, yeah?
Yeah.
You add it together, divide by 2, which is 2.5. That's medium.
Yeah.
Got it? Okay, so today we're going to introduce another concept called mode. Mode. What's mode?
Oh, it's 2.
Here it's 2. Yeah, it's the most
Yeah.
appearing. Yeah, most appearing one, which is 2.
I
Because
knew
2.
that.
Okay, 2 appears 3 times, so it's the mode. Okay. Okay, so let's a little bit review. So another concept, lucky number.
Lucky number.
Okay, so lucky number is that.
Have we thought about that before?
No. Let's put it into 3. Okay. So how many times 1 appears?
1,
How many times 2 appears?
2,
How many times 3 appears?
2,
How many times 4 appear?
1.
Okay, so if they appear the same number of times equal to the value itself, it's a called lucky number, right?
That one and that one.
That one and that one, yeah. And we need to return the largest one, which is 2. Does it make sense?
Yeah.
So if a number appears n times, and then if the value is n, then it's a lucky number. And we need to find the number of the, yeah?
Does it have to be sorted?
No, it doesn't.
How about
no.
1 and 1?
1 and 1 will be 2 times, then it's not a lucky number. And sometimes it doesn't have this number and return -1, right? For example, 1, 1, 2. Okay, 1 appears how many times?
2,
2 appears how many times?
1,
So there's no lucky number, return -1, okay?
-1.
Yeah, does it make sense?
Yeah.
Okay, so how can we do this? How can we do this? Any idea? There are a couple of ways to. Notebook, well done. And how will you implement the notebook?
Knock.
How will you implement
We
the
put all of them in and the
Remember in Python, how do we use the object in start with what kind of object and can allow us to recall to find the number of frequencies occurrence for each item. What's that called?
I think if we can do
C. What's that called? C-O-U.
count.
Counter. Remember? Okay. Look. Define. Largest lucky number. Okay. Number. Okay. Let's call it nums. And what's missing?
Color.
Okay. Look. Counter equals counter. Yeah.
C equals
Nums.
counter. You mean
So what's C now? What's C now?
counters.
Counter. What's C now?
Counter.
Yeah. And what does it contain?
It contains the how many numbers.
The key and the value. Yeah. What
Yeah.
key is the number, and the value is the number of times they appear.
Yeah.
Okay. And then now what should we do? What should we do?
If
Look, we can appear. We can put it the order. We can put all the lucky number in this list first. Okay. So let's do this. For I in what? In C, right? The iterate with the key. If the key equals the value Ci, right? and I push it into. Well, we found a lucky number, right?
Yeah.
I is the value. Ci is the number of times they appear, right?
Hmm?
Answer the append I, right? And then we need to look if answer, if there is a lucky number, then return max. We want to return the maximum, right?
Hmm?
Yeah. And then return -1 here, right? Right? Does it make sense?
Hmm?
Yeah. What's the time complexity? What? Oh what? Oh what? How many times? How many iterations?
O(n).
O(n). Yeah. What's the space complexity?
Okay.
Yeah. We're done.
Because I'm using a notebook.
And A is the number of.
Oh, nice list.
There's no the numbers in the list. Okay.
Yeah.
Look here. Wait.
Do you feel that pen drop?
Look, counter and answer. We can show.
My magic.
Look. If answer return that, yeah, we can return max answer if answer else -1. Yeah,
Oh,
you
yeah.
can write this in one sentence. Yeah, return max. It's the same thing. Yeah, return max answer if answer. Yeah, else -1. Okay. Yeah, you can write it this way. This is called Pythonic way. Okay. Sometimes people programming in Python they like to write this kind of code, but this is more clear. Yeah, if answer, if there are items in the answer, if there are more than, if there's a lucky number, we return maximum of it, right?
Hmm.
Yeah. Otherwise, we return -1. And we can also do what? We can also do this. Return max what? Max I for I in C if I equals Ci, right? And otherwise how can we do it? Let me just no, maybe we need to do this 2 step. I saw, look here, this one, yeah. We can do this. We can combine these two into one sentence. Answer equals what? I for I in C if I equals Ci, right? Right?
Hmm.
You see? So this is the least comprehension. So look, I create a list which contains the element I. But what is I? I is in C. And what condition? If I equals Ci. So it's the same thing as this, right? Alright? Does it make sense?
Yeah.
But you're not required to remember this. This is a fancy way, fancy syntax sugars. You know what's syntax sugar? A much neat way to write it. But this is also does the same thing. Does it make sense?
Need a column.
No. It's all one none. Return back if answer else. It's all one none. Okay. Okay. So can we do it without the notebook? Because notebook.
Brute forcing.
Yeah. We're
It
done.
takes super slow.
Maybe not. Okay. Look.
It might be take O(n) square.
We're done. Brute forcing in this case is O(n) square. Okay. So
Yeah.
look. Look. We are trading the space. That's okay. We are trading the space with the time. Okay. Okay. We are trading the space. Here we are using the O(n) space counter, right?
Yeah.
Okay. So how can we do brute force? How can we brute force? We iterate through each number, right? Yes. You tell me how to do brute force. Brute force. Okay. Brute force. Num. Okay.
Column.
Look. Let's do answer equals -1. Okay. Let's suppose there's initially we can't find the lucky number, right?
Mm-hmm.
Yeah. Okay. So now we need to for I in nums, right? We go through each number, right? Am I right, Eric?
Yeah.
But for each number, what we need to do? We need to count it how many times, right?
Yeah.
So we can use this. If nums, look Eric, dot count. Yeah, that's a function called count. Count what? Count I. If equals I, right? Right? Alright?
Yeah.
Then I is the lucky number. So what should we do with the I?
Put it in the answer.
There's no answer is the value. We don't have a list now. What we need to, you can put it in a list, right? then you will be return maximum I answer, right? If there's but we can do this. Look, then we can say if I is bigger than answer, right? Right? Answer equals I, right? Alright? And I can just return answer. Alright? Does it make sense? Does it make sense?
Yeah.
All this one you can just do this. Answer equals max answer I. Does it make sense? Look, we are iterating these numbers. Each number. We'll try each number. And we count how many times it appears in the list, right? If it appears in the same value of times, then this is a lucky number, right? And we need to store the largest lucky number, right? What's the time complexity?
O.
O1.
N squared.
Why is O(n) squared?
Cause brief was index learn O n squared. Oh, because this and this.
Where down? Look, this is
Awesome.
n. Where down? This is O(n). But this count, look, this is count. Counting this number in an array takes another n, right?
Yeah.
So this is 4, and inside it needs another 4. That's O(n) squared. What's the space complexity?
O n. Log n. 1.
O1, because we're not using any space, okay? We're not using any space. We're not.
Yeah.
Can we do better brute force?
There is space.
It's a constant space. It's not actually the space. The O1. You can create a variable. It doesn't matter. This is O1 constant. Means that there are constant number of the spaces, right? Because if the n numbers.
Easter egg on this chair.
Okay.
Mmm.
Eric.
Yeah.
Because if the numbers, they are abelian numbers, we still need to use one variable, right? It doesn't change, right? That's why I call O1 constant, okay? So how can we do better? How can we do better? Look, how can we do better? We can sort the numbers from the largest to the smallest.
Yeah.
And what? And what? We can sort the numbers from, look, if 3, we can sort the number 3, 2, 2, 1, right? We sort the number from largest one to smallest, right? And we go through this. If this is not the same as the next number, if it's not the same as next number, then I will check. If it's the same as next number, I will increment the count. And now look, if these two, they are two, right? And it's the same, then I will return it because I always try from the largest to the smallest, right?
Yeah.
I will immediately return the first lucky number, am I right?
Yeah.
Does it make sense? I don't need to find the largest, right?
Yeah.
Okay, can you repeat?
Okay, then you find from the largest.
Why?
So you sorted from the largest to the smallest because you're finding the largest lucky number. So you don't. So if you found it, you just return it. No going further.
Because the first lucky number find will be the largest, right?
Yeah.
Because I already sorted from the largest to the smallest, so I go
That's
through
what I
that.
said.
Well done. But you need to express it, say slowly. Other people can understand, okay? You say, nobody understands what it means. Only daddy.
I can.
Okay. Okay, so let's do this. Lambs got saw. What's the time complexity of this one? Every time about the sorting, you need to remember.
O(n) square. O(n) log n.
O(n) log n.
Yeah.
If it's sorting, it's O(n) log n. Yeah. If we use the dot sort, yeah. Just remember,
That's
yeah. Yeah. Because we are using the quick sort, merge sort, yeah. Every time I half anyone, right? Look, Eric, merge sort. How to merge sort?
Cut it.
So look, I merge from two numbers. I know how to merge two numbers, yeah. And right? And then two numbers merge two numbers. I know how to do it, yeah. Right? And then four numbers merge four numbers, yeah. You see? Remember how we merge two sorted lists, right? We have 2 pointers going through comparing each, yeah. Correct? Okay. After sort, and then we have a number of the, let's call it streak. Do you know what's streak? The number of counter for the current number, yeah. Streak. C equals 0, and then for I in nums. Because yeah, look, this sort is from the smallest to the largest. So now I need to add a keyword, reverse equals true, right? Then it will be from the largest to the smallest. Am I right?
Mm.
Yeah. And the time complexity will be still the same. Okay. For I in numbers, then I will see plus equals 1, right? Right? Yeah. The current number. And if probably I'm not going to the numbers. I will go into the range, the indexes, length, lambs. Okay, because I need to use the indexes. If what? If it's the last number, len, lam, -1, or what? Or if the lambs I not equals next numbers, okay? If it's not equals the next numbers, so what should we do? If C equals if C equals nums I, right? This is a lucky number, right? Then we return C, right? Otherwise what? Otherwise we need to set C equals 0 and then return -1. Does it make sense?
Mm.
Take a minute to think about it and I'm going to ask you questions, okay?
Why?
Because I need to check if you understand.
Why?
Stop saying that, alright?
Why?
Okay.
Okay, what?
Okay. Look, Eric, right.
What?
So, Ryan, naughty.
Oh.
I will go through the ranges, each index, right? And then I will increment the current number counter. Strike C will be equals 1. And if it's if it doesn't go inside, it means the current number is equals to the next number, right? Right?
Yeah.
And then the next iteration C will be equals 2, right? And then now look, if it's the last number or if it's not equals to the next number, what does it mean? If it's not equal to the next number, then it means that the current number appears C times, right?
Yeah.
And what's this if C equals nums I, what does it mean?
C equals nums I. It means that it's a lucky number.
Well done, and I will return the first lucky number, right?
Yeah.
And if it's not a lucky number, what should I do? I should reset the stack. So the next iteration will be appearing 1 time, right? Appearing 2 times, appearing 3 times. Does it make sense?
Yeah.
What's the time complexity?
O-N. Log N.
Okay, is that a separate sentence or?
O-N log N.
O-N log N. This one is O-N, right?
O bracket N L-O-G-N bracket.
Okay, so look, this algorithm consists of 2 parts. The sorting, and this O-N part. Which is dominating? Which is bigger?
This. No, this.
This one, yeah? O-N log N, because it's time, log N, yeah? Log N could be bigger than 1, right?
Yeah.
Yeah? So this one is most time consuming part. So when we talk about algorithm, we pick the most dominant part, which is this one.
Yeah, and you got that one.
Yeah. Okay. Does it make sense?
Yeah.
Okay. And if I tell you, if the numbers are already sorted, if like numbers
the
are,
largest to the smallest.
yes. And what's the time complexity?
O-N.
O-N.
Yeah.
O-N. And you just erase this. O-N, okay? Stop checking, okay? Okay, and I'm going to erase this, okay? So what should I put here?
Where?
Yeah.
And what else?
Just that part. You want to do 2 together. You want to,
If
what?
in-
The what? What? If what? You just say if it's a lucky number. How do you write it?
If I in range.
What?
If I.
Not I. Which one is the counter?
C.
C equals what?
C.
Equals what?
I. No.
What's that? I is the ranges. What's the value at I?
I. 0.
What's the value? I is the ranges, index. So what's the value at index I? The lumps array. What's the index?
Something about 1 plus equals
Come on.
1. I'm thinking something about I.
Yeah, it's something about I, but the list is lumps. And what's
C.
the
I.
C is an integer. If C, this is the number of times that appears. Which number appears? Come on, this is the list. This is the list. And what's the I? Index I. What's the index I? How do you write it? The first number is number 0. And what's the i's number?
0. Nums I.
Yeah, come on. Oh my God. Come on. Be confident, okay? You see, you just saw that and then I erase it. I ask you and you're not sure. Does it make sense? You forgot something.
Column.
Yeah, let's not break it. Does it make sense, Eric?
Yeah.
Does it make sense?
Yeah.
Okay, I'm going to erase one more time. What did I erase?
You ready?
Here. Mr. Yeah.
What did I erase?
Return.
Come on, come on. Come on, what should I do with the C? Every time C is the number of times.
C equals 1.
Come on, be confident, okay? Should I go erase one more? Huh? Okay, what's this?
Return
answer.
No return answer, return what?
-1.
Come on.
I'm listening.
Okay, you're listening. Okay, that's it for today. Bye bye.
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 Oh yeah.